Okay, today we're going to be talking about sigma notation and how this sigma notation plays into our area under the curve, how that's going to help us find area under the curve. So reviewing sigma notation, remember that sigma notation, okay, you have some sigma starting from some number to your final number, one number to your final number, and then we have some function in here. And you'd plug in 1, 2, and 3, and 4, all the way until you get to n. So I have some examples of sigma notation down here. You plug in 1, 2, 3, 4, 5 into this function all the way until you get to 6. And then you'd sum all of these numbers up. This last one, C, is where we're going to. Okay, this is kind of the goal of today's lesson and understanding what this all means. We're going to be summing up some different function values times by a delta x. And in terms of our rectangles, if you think about the Riemann sums or the rectangles that we built in the last lesson, this was the height and that was the width. And we're going to be summing up all of those in terms of some sigma notation. And we're going to be doing some pretty hefty math today, okay? So some summation formulas, okay? If you have just a constant in there, you can simplify that out by writing C times n. That sum is going to equal whatever your constant is times by n. If you have a linear function in here, so like say it's just x, you would take n times n plus 1 over 2. If you had I squared, n plus n plus 1 plus 2n plus 1 over 6. And then I to the third is going to be this formula. I don't even think I used this formula in my notes. I will tell you guys right now, these summation formulas you don't need to memorize. I really like this lesson. I think it's an important lesson, but it's not, it leads us into where we want to go, okay? So I would give you guys these summation formulas, and quite honestly, I'm going to show you guys during class, remind me, and I'm going to keep reminding you guys to remind me, to show you guys how to do some of this work on your calculator, okay? So this first example here, anything with an n in it, we can kind of pull that out in front of our summation formula. So I'm left with I squared plus 3. So now looking at that, using these summation formulas, we have the 1 over n cubed. We have I squared, which is this formula here. And that's n times n plus 1 times 2n plus 1 all over 6 plus, when I have a constant, I use this formula, 3n. Now at this point, you can choose to simplify. Going through and simplifying, I did all of my algebra on this one, and I get 1/3 plus 1 over 2n plus 19 over 6n cubed. And that's just doing a whole bunch of algebra. I'm not going to bore you guys in this video with the algebra because that video would be 3 hours long. Okay? So now, if I plug in 10 to this, and I would just put this in my calculator in like a y1, and then do y1 evaluated at 10. Okay, to get my 10, I get 0.415. To get 100, we get 0.33865. When I plug in 1,000, we get 0.33384. When I plug in 10,000, I get 0.33338. Notice how as the ends keep getting bigger, what does this keep going to? Basically what you're kind of looking at here and where we're going to lead you guys through this lesson is as n goes to infinity of this function, hopefully you see from your infinite limits that this is going to go to 1/3. Okay, so that's kind of where we're going to be going with this video. Okay, this concept of summation notation is going to help us approximate the area under the curve. So I have 5 rectangles here, and I'm going to approximate the area from 0 to 2. Remember that delta x is b minus a over n, and they want us to use 5. So my delta x is 2/5. So this first one is at 2/5. And then I'm at my second delta x is 4/5. My third one is 6/5. My fourth one, 8/5. And lastly, my last one is 10/5 or 2. So remember when we're using our rectangles, okay, we take 2/5 f of 2/5 plus f of 4/5 plus f of 6/5 plus f of 8/5 plus f of, I'm going to leave it as 10/5. There's a reason that I'm doing this, because I kind of want to put this into this summation for us. Okay, so I have the 2/5 times by f of 2/5 plus f of 2 times 2/5 plus f of 3 times 2/5 plus f of 4 times 2/5 plus f of 5 times 2/5. Okay, so notice how I have now kind of like a summation in here. I have 2/5. The summation from 1 to 5, 1, there's a hidden 1 there, to 5 of my f of 2/5 I. And you can use any variable there. We typically use I, N, or K. Okay. So now writing this another way, the function that I'm talking about the function that I have here is 8 minus x squared. Now, I'm not going to lie. You could use these formulas. You could use these formulas from this other slide. And you're welcome to do that. If you want to memorize them, if I don't give them to you, I would typically give them to you. But just throw this in your calculator. Okay? So throwing this in your calculator, I get 12.48. And remember, remind me during class, I'll show you guys how to find that in your calculator. If you go to the math menu, you should see a summation formula, summation piece on there, okay? But I'll show you guys that on your calculator. Okay. Now we're starting, and we have a different rectangle. Here I'm starting at 0. And then our delta x is still the same fifths. Same thing, which is 2/5. Okay, so this is kind of an over approximation. So here we're going to be looking at 2/5 f of 0 plus f of 2/5 plus f of 4/5 plus f of 6/5 plus f of 8/5. So again, in terms of it'd be 0 times 2/5 plus f of 1 times 2/5 plus f of 2 times 2/5 plus f of 3 times 2/5 plus f of 4 times 2/5. Okay, so now writing that in our summation notation, I make it easier. The book always starts with your summation down here being 1, so it would adjust it a little bit. I'll try and adjust that in a minute and see if I can do that for you guys. But I'm going to start at 0 since I started at 0 there. And I go to 4 because I went to 4 there. And we have f of 2/5 I. Or again, remembering our function is 8 minus 2/5 x, but I'm not using x here, I'm using i's, I squared. And again, typing that in your calculator, you get 14.08. Another way to write this involving, if you want to write it at 1, and I'm going to be doing that for something that we do here in a minute, you'd write 2/5 times I minus 1. I think that's a little bit more complicated because then I would get 2/5 I equals 1 to 5 of 8 minus, this whole thing is my x, so that's 2/5 I minus 1 squared, and you should get 1408. I'm going to pause the video and try that on my calculator here real quick. And after our short commercial break, I just did this in my calculator, and I also get 14.08. So you do get the same thing both ways. I'm going to be using the second way in the next example, just because I was just checking my answer with the book and making sure everything worked out to be the same thing. Okay, so again, our whole goal is to find area under the curve. And I've kind of talked about this, where we divide a to b into n subintervals. And so we get a delta x. Okay, so we get a width, and we multiply by a height. And our lower sum, so if all of our rectangles are underneath. That's why in the last slide I talked about the rectangles being underneath. Or I'm sorry, not the last slide, in the last video. And then we talked about the rectangles being over. So an upper sum. So a lower sum you're under, upper sum you're above, and the area of the region is somewhere in between there. Okay? And what the book has us doing is it has us doing a whole lot of algebra to find this lower sum and upper sum, and eventually we're going to be using this concept of limits to get the actual value. And then in a few days I'm going to teach you a shortcut. Okay? Okay. So, find the upper and lower sums for the rectangle bounded by that graph, and the x-axis from 0 to 2. Okay, so my delta x is 2 minus 0 over n, or 2 over n. Okay, for the left endpoint, okay, they call it, I'm going to go back to the previous slide, they call this, the x value there, m sub I. So I'm just using the same notation as the book because that's what my notes are in, so I don't make a mistake. So the m sub I, or like the x value, is going to be, since it's left endpoint, it's starting at 0, plus I minus 1, remember I did that in the last slide, times by delta x, which equals 2I minus 1 over n. Okay? So for my left endpoint, we are doing the summation from I equals 1 to n of 1/4 my function, okay? So actually, let me go back a step here. F of m sub I times by delta x. So again, what that equals. Okay, so my function is 1/4 x squared delta x. Just my x is this 2I minus 1 all over n. Okay, so my best advice here is to simplify everything out. Pull out anything that has an n in it. So actually, let me do one more simplification here. I have a 1/4. I have a 4 over an n squared. Because I take the squared and I bring it to the 2, I bring it to the n, I bring it to the I minus 1 squared times by the 2n. So anything that is a 1/4 or has an n in it, you can bring out in front. Okay, so I didn't leave myself enough room out front. So simplifying all that out, I end up with 2 over n cubed up front. And then I would have this I minus 1 squared. What I would do personally is I would multiply that out. You get I squared minus 2n plus 1. And using all those crazy formulas from the very beginning, and I'll write them out for you, but I'm not going to go through all the work of simplifying. You get the I squared formula is n plus 1, 2n plus 1 over 6 minus 2. The formula for n is n times n plus 1 over 2, and then plus an n. Now simplifying all that out and going through and simplifying all that out, you would get this. So that is the lower sum formula, okay, for this graph, okay? The right endpoint, in my opinion, makes a little bit more sense, okay? So the right endpoint, our delta x is still the same. They called it big M sub I is 0 plus your I times your delta x. So again, my right summation formula so again, you're just doing the same thing. And I have 1/4. I was thinking about the squared that I had to write. 1/4 x squared delta x. Just this x squared is a little bit nicer. Okay, so simplifying all that out, okay, pulling the anything that has an n in it out in front. Okay, so then doing this formula, that I gave you guys. And simplifying that out, you get this. So again, this is a formula that's going to help us find the area depending on the number of rectangles we have. Okay? Okay, so let's talk about what all this means. What all this means is if I have b continuous and non-negative on the interval from a to b, the area of the region bounded by the x-axis is the limit as n goes to infinity of the summation formulas we've been finding. Okay? And this is going to be really, really important to us. Okay, so again, the area is the limit as n goes to infinity of those formulas. So now going back. Okay, so now going back, if I look at this and I take the limit as n goes to infinity of the 2/3 minus 1 over n plus 1 over n cubed. I think that's right. I know there should be a 3 here. I was wondering why that didn't look right. As that goes to infinity, I get 2/3. So now looking here at this one, I'm sorry, I'm really excited because I'm making a connection that a lot of my students haven't made because our old book really didn't do this. As that goes to infinity, that is 2/3. 2/3, not 2 over 2. Remind me in class, I'll show you guys. Actually, no, I'm not going to tell you what I'm going to show you. Haha, I lied to you. Okay, so the key takeaway is that we're using those formulas to get we're using the summation formula to get our area under the curve by using limits. And that's going to be super important to us. One last example. Okay, and I'm going to rewrite that. Limit as n goes to infinity of my summation what was it, c sub I delta x? Yes. We're going to use the area of the region bounded by this graph and the x-axis between 0 and 1. Okay, so my delta x is 1 over n. My f sub c sub I, well, that's really limit as n goes to infinity of my summation of f of x, so that's 2 c sub I is I over n, okay, I times your delta x, 2 I over n squared times by delta x. So simplifying all that out, bring out anything that's that is a that had an n in it, using those formulas from the very beginning of class. Oh, I'm sorry, this is a long video, guys. Now finding this limit, okay, just so that you guys know, when I find this limit and I simplify that, I feel like that formula shows up a lot here. This all simplifies also to 2/3. It's just the examples I picked that they all work out to be 2/3. They're not always all going to work out to be 2/3. But that is your kind of introduction to area under the curve. This is kind of like the long way. Remember when we did derivatives and I made you guys use the limits? Okay, that was the long way. This is kind of the long way. As we work through the chapter, I promise I'm going to teach you shortcuts. I apologize for the super long video, but I think that this concept is really, really important for you all to understand. Okay, please make sure you have what you need ready for class.